All right, time for the 9.2 homework. Okay, so it says in number 71, what is the inverse of h of x equals x squared plus 10 if the domain of h of x is not restricted? Is its inverse a function or just a relation? Explain your answer. Okay, so let's find the inverse of h of x. So let's change the h of x to a y. And then Freaky Friday, change the x and y's places. So x equals y squared plus 10. We need to subtract 10 from both sides so we can start solving for y. We'll get x minus 10 equals y squared. And then how do we undo something that is squared? If you're saying square rooted at the computer, you are right. And because we're taking a square root and we're solving and we're getting a variable, we have to put plus or minus. So I'm going to flip this around to y equals plus or minus the square root of x minus 10. So let me rewrite this so that it's in the right notation. So h inverse of x equals plus or minus the square root of x minus 10. Okay, so it says if the domain is not restricted, so we're not restricting the domain on the parabola, is its inverse a function or a relation? Well, we know that this is a square root function and it's got the plus side and the minus side, so we know that it's going to be a sideways parabola. That won't pass the vertical line test. So it's a relation, but not a function. So is its inverse function a function or relation? The inverse of h of x is a relation since it will not pass the VLT, the vertical line test, period. I guess I could have used that as my period. So its inverse is not a function. And your write-up could be similar, but it does not have to be the same exact wording as mine. Right? Plus, this is after the fact. So if you're copying down my wording, that's not cool. That's plagiarism. All right, number 72 says to state whether the domain of each function must be restricted to ensure that its inverse is a function. Give an appropriate restriction where needed. So number 72 is a parabola because it's to the second power. Let me zoom in a little bit. And we know this is a parabola shifted to the right 6. So if I were to do a quick graph, 1, 2, 3, 4, 5, 6, this parabola would be right over here. Okay, but we know that the inverse of a parabola is a sideways parabola, and we don't want that. We only want half of it to show. So we do have to restrict the domain. So the domain must be restricted in order for its inverse to be a function. There's two ways that we can restrict it. We can either chop off the left half or we could chop off the right half. So, and it's all in terms of that x value of 6. So the domain must either be x greater than or equal to 6. That means we're chopping off the negative side. Or x less than or equal to 6 and we chop off the positive side. That way only one of those sides will show up on the inverse. H of x, number 73. H of x equals the square root of x plus 11 minus 2. This is a square root function. Okay, so that means that it's going to pass the vertical line test and the horizontal line test. So this is 1 to 1. So since it is 1 to 1, that means that I don't need to restrict anything. Its inverse will only be half of a parabola. it'll be the positive half since this is the positive square root. So there will be no restrictions necessary. We don't have to restrict a square root. When we're starting with a square root function, we don't have to restrict it. Only when we start with the parabolas. Speaking of which, number 74, p of x equals x squared minus 10x plus 25. Now, we don't know where it's located on the graph, but we do know that this is a parabola. So we are going to have to restrict the domain. Okay, so the domain must be restricted. But we need to say how to restrict it. So that means we do need to rewrite this. So it'll be p of x equals x squared minus 10x plus 25. I believe that's factorable. So let's see. Two numbers that multiply to 25 and add up to negative 10. Well, 5 times 5. So negative 5 and negative 5, because that will add up to negative 10. Hey, I have two of the same thing. So can't I write that as x minus 5 quantity squared? There we go. It's in vertex form then. So this is shifted to the right 5. So I know, 1, 2, 3, 4, 5, that this parabola is right there. Okay, so to restrict the domain, we either have to chop off the negative side or the positive side. So x has to be greater than or equal to 5 or less than or equal to 5. Okay. Number 75. Monique is told that the function f of x equals negative x to the fourth plus 5 has a value of negative 11 for a certain x. She says that x must be 2 because she determines that f of 2 equals negative 11. Is she correct? Well, let's try this. F of 2 equals negative 2 to the fourth plus 5. 2 times 2 is 8. 8 times 2 is 16. Hold on. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. I was getting ahead of myself. So that would be negative 16 plus 5, which equals negative 11. Right. But is that the only x value that's going to equal a y of negative 11? What if I have f of negative 2? Because isn't a negative number raised to an even power still going to be positive? So wouldn't it be the same thing? Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is a negative 16. Or sorry, positive 16. With that negative out front, it's still negative 16 plus 5, which is negative 11. So it's not just a 2, it's also a negative 2. So we're going to say, is she correct? No. Because f of negative 2 equals negative 11 also. I must have liked that blue pen because I used it a couple of times. All right, number 76. Moving my pens. Says which function is 1-to-1? So to be 1-to-1, that means that the original function passes both the vertical line test and the horizontal line test. Letter A, this is a parabola. Parabolas always pass the vertical line test, but they never pass the horizontal line test. So this one is not 1-to-1. X to the fourth is similar to a parabola. It's the funky W. So these ones always pass the vertical line test, but they will never pass the horizontal line test. So that one is not 1-to-1. F of x equals 1/3 x. Well, its inverse would be the reciprocal, so just 3x. Okay, those are easy. So yeah, that would be 1-to-1 because that line, this line and that line both pass the vertical and horizontal line test. What about f of x equals 12? Well, this is the same as saying y equals 12. Well, y equals 12 is a horizontal line. The inverse of a horizontal line would be a vertical line at x equals 12. And vertical lines don't pass vertical line test. So, and a horizontal line doesn't pass both the vertical and horizontal line test. So this one is a no. Okay. So B is the answer to 76. 77. Let's see. We have, which function is the inverse of g of x equals x squared minus 5? Well, let's do it. Actually, there's a quick way. This is a vertical move, down 5. So the inverse function, focus, is we know this is a x squared, so we know its inverse is going to be a square root. Okay? But since this is a vertical move, its inverse is going to have that 5 as a horizontal move, but it has to be the same direction. It has to be a negative move. So this is going down 5, so it's a negative move. What would be a negative move on the inside? It would be a plus 5 because that would be going to the left. So it is letter A. Now, if that confuses you, you can always Freaky Friday it and find out that way. So switch x and y's places. Solve for y, so add 5 to both sides. We will get x plus 5 equals y squared. Undo the square by square rooting, and y equals the square root of x plus 5. Yep, there it is. Whoop, there it is. All right, number 78. Carl writes the domain of g of x equals the square root of x minus 7 is 7 to infinity because it has no real number value for x less than or equal to 7. Do you agree? It does have a real number value. We know that this is shifted to the right 7. So that means 1, 2, 3, 4, 5, 6, 7. It's right there. It has an end point on the point 70. So I don't agree with Carl. So I'm going to say no. I don't agree with him. The domain should be a square bracket on the 7 to infinity. Carl didn't include the 7. Oh, Carl. At least you tried. Number 79, the last one, because we're not doing number 80, says find the inverse g inverse of x to g of x equals the square root of x minus 4. State the domain and range of both functions, it looks like, using inequality set notation and interval notation. Graph both functions on the same axes. Okay, I'm going to start with the graphing. So first of all, g of x is the square root of x minus 4. So that means that we get to shift it to the right 4 units from the parent function. So the parent function would start at 0, 0, go to the right 4, 1, 2, 3, 4. Okay, and there's no vertical stretch or shrink, so I know that up 1 over 1 is the next point, and those 2 points are good enough to graph. And there is g of x, always got to label it. Okay, let's graph the inverse. So just take that point. This point right here is 1, 2, 3, 4, 0. Freaky Friday it, and you get 0, 1, 2, 3, 4. And then the point here would be 5, 1. Freaky Friday it. You get 1, 5. Now you have to remember what the shape of the graph is, otherwise you might connect those 2 dots and think it's a line. It's not. The inverse of a square root is always half a parabola. And let's label this g inverse of x. So we have it graphed. Now we have to do the domain and range of each of those functions in those 3 different types of notations. So I'm going to do that over to the right. What color do I want to use? I think I'll use black. So let's start with g of x. All right, the domain of g of x. Well, the lowest x value it's using is that 4. So from 4 to positive infinity. So in inequality notation, x is greater than or equal to 4. In set notation, it would be x such that x is greater than or equal to 4. And then in interval notation, it would be square bracket on the 4, comma, infinity, close with a parentheses. The range, well, the lowest y value it's using is 0. It's not going below the x-axis. So y has to be greater than or equal to 0. In set notation, that would be y such that y is greater than or equal to 0. In interval notation, that would be square bracket on the 0 to positive infinity, close with a parentheses. And then g inverse of x, domain and range, it should be the reverse of these, Freaky Friday then. So I'm going to look at the range, but instead of y, because it's domain for the inverse, I'm going to put x greater than or equal to 0, which makes sense because the lowest x value it's using here is 0. And then set notation would be x such that x is greater than or equal to 0. And then interval notation would be square bracket on the 0 to positive infinity. And then the range should be exactly like the domain of g of x, just instead of x put y because we're talking about the range of the inverse. So y greater than or equal to 4. In set notation, y such that y is greater than or equal to 4. And then square bracket 4 to positive infinity. And there we go. And that's it.